In the last session, we had seen some important conclusions about the balanced load and balanced source. So, in which we considered the two cases. One is four wire system. The case one is neutral impedance is zero. That means in the neutral line there will not be any impedance. Impedance is zero. So in that case, our ultimate aim is to find the line currents, that is IRL, IRY, IR, IBL, IYL. So these are the line currents. Other objective is to find the neutral current. So we had seen the important conclusion from case 1 that in a balanced system, the neutral current is zero. In a balanced system, the neutral current is zero. This is very important conclusion. So you have to observe carefully. So irrespective of the thing, whether it is of different kind of system, different kind of load, but once it is balanced, neutral current is zero. That is important. Next is with the neutral impedance non-zero. So we are trying to find some things. So I asked to find the neutral voltage. So thereby we can find the line currents or phase currents. So for which, let us take again three loops. One is R phase loop, Y phase loop, and Z phase loop. For which, let us write the KVL. So we can write the KVL in this way. So you can start over here, and this is VR. So VR plus VR. Next, this is neutral voltage, that is IN into ZN. We can write as plus VN. So why I am writing plus, that you should understand. First I am coming across the arrowhead. If it is non-arrowhead, I will write negative. So here it is non-arrowhead ER, so minus ER is equal to 0. I am considering three different loops with the help of R phase line and neutral, Y phase line and neutral, B phase line and neutral. So for these three cases, we will write the KVL. And here our objective is, let me write here, to find the line currents first. I'll write as IL. Once we know the line currents, I can find the IP phase currents. Then once we know the phase currents, we can find the neutral current, which is sum of the line currents or sum of the phase currents. And after getting the neutral current, we need to find the neutral voltage also, Vn or V small n or capital N, it's your use, whichever notation you adapt. So these are the some of the objectives. So for which, what we need to find is that first let us put up the things in the currents. So what I will do is that this ER is the source voltage, I don't want to disturb, and Vn is the neutral line voltage, so I want to keep as it is. First I will find the neutral line voltage. Then VR, that is these all are of course phasors, so try to understand that. So VR is the voltage across ZR, which can be written as IRL into ZR. IRL into ZR. So let me write as IRL into ZR plus VN minus ER is equal to 0. Now from this you can find the line current IRL phasor is equal to ER phasor minus VN phasor divided by ZR. ZR. So let us call this as equation number 1. So we will use this equation in the next, like after finding remaining two line currents. So in the similar way, so I request you to write down the KVL for this and write Vy is equal to IYL into ZY. Thereby you will get, similarly, I'll write in this way, IYL is equal to EY bar, this is EY voltage, generator voltage, minus neutral line voltage, that is Vn. This voltage is also considered as Vn. So Vn phasor divided by Zy. So this is, let us say, equation number 2. Similarly, for this loop, we will get equation number 3 as IBL is equal to EB phasor minus EB phasor minus, so Vn neutral voltage divided by ZB. ZB. Now let me call this as equation number 3. So once I consider these three cases together as like this diagram, see that neutral current IN is equal to sum of these three currents, that is IR, IY and IB. So now from the KCL, I can write in this way: KCL, KCL at at node n, small n, node n will gives the neutral current IN is equal to IR IRL plus IYL plus IBL. Now let us put up all these equations in proper form. So can I write IN is equal to Vn divided by Zn? Current is equal to voltage by impedance. What is the voltage? Voltage across the neutral line impedance is Vn. Impedance of the neutral is Zn. So I had written this I capital N as Vn by Zn. Similarly, IRL we already derived from equation number 1. What can we write? ER minus Vn divided by, tell me, ZR. So plus IYL is equal to EY minus Vn divided by ZY. Similarly, other things. So EB minus Vn, all are phasors, divided by ZB. Now from this you simplify and try to get the neutral line voltage Vn. So for which what can we do is that we can bring all Vn to one side. So this Vn by Zr, Vn by Zy, Vn by Zb. And we can take Vn common. What we will get? 1 by Zr, or let us say 1 by Zn, first one, this one. If this comes to the left side, so 1 by Zr, are you getting? Plus 1 by Zy plus 1 by Zb. This is if we take Vn common and if we bring all Vn to left side. So is equal to ER divided by ZR plus EY divided by ZY plus EB divided by ZB. Now from this you can write the Vn equation. Vn is equal to, this is very important equation. So you can write this numerator divided by the denominator part, let me make small size, divided by this expression, that is 1 by Zy, 1 by Zr, 1 by Zy and B. So in this way you can get the neutral voltage as, once we know the source voltage and the load impedances. Once you know the source voltage and the load impedances, so we can get all these things. So this is very important expression. So try to observe how they have come into the final expression is that, so ER by ZR, that is R phase corresponding source voltage divided by R phase corresponding impedance. Similarly, EY by ZY, EB by ZB divided by reciprocal sum of all the impedances. What are the impedance? Three lines, three phases impedance plus neutral impedance. Plus neutral impedance. Is this clear? Yeah. So this is very very important expression that you should observe carefully. And in this you can see what happens when 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 Zn is equal to 0. When Zn is equal to 0, what happens? Think. Vn is equal to 0. It is simple. Vn is equal to 0. That means you no need to determine all these expression and entire thing. So Zn is equal to 0 means you are obviously the voltage drop across the neutral line is 0. Here you can observe that if Zn is 0, the current into the impedance is the voltage. So impedance is 0 means Vn is 0. So that is very good observation that you need to find out. And some other observations I will give through the numerical examples. So instead of just going through all these non-numerical derivations, so that may not be give the flavor of the subject, that's why I thought to give some numerical problems in this way, right? So now see this problem, read carefully step by step. So like how I am solving that, you should observe and you should imitate in the same way, and you should get complete awareness on the subject. So all things are the practice makes you perfect. That's only the solution for this subject, no other things. So I am telling you, if I live 2 years, if I want to do any problem, then in the third year if I'll teach this subject, so I may do some calculation mistake, no doubt in that. So that is the thing. So any person can make mistakes, so that can be rectified only through practice. That is one thing. Other thing is that if you take this in this way, like question, and put in your notebook in front of you and think how to approach, how to get the solutions. In that thinking process you will get many doubts. So many people will say no doubts are no doubts are no doubts are means you are not at all practicing, you are not at all doing problems. That may be the reason. But once you put like this problem in your notebook and trying to solve it, even if you know the solution, again you do it, whether you could reach the right answer or not, check it. So that is my suggestion. So here now try to observe that what are the things given. So they said that EAN is equal to 120 volts at an angle of 0 degrees. 120 at an angle of 0 degree. And they didn't said anything about B phase and C phase voltages. I told you we can assume RYB or ABC phases also. It all depends on individual interest. So this is something like coil 1. So this is coil 2. This is coil 3. So three coils are connected in star fashion. Try to observe. And that corresponding thing, that corresponding common point we are considering as a neutral. Generally source neutral we represent capital letter, load neutral we represent small case letter. That also you observe. And apart from the previous informations, one extra information is that previously this was 0. Try to observe in my derivation there is no impedance existing between the R phase to R phase load, but here some impedance is there. This we call as a line impedance. So you will see transmission lines on tower where conductors are there that may have small impedance also. That is, this is more practical problem. Like imagine somewhere generating station is there. So nearest to your place, if something is there, if you are near to Vijayawada, so you can take Vijayawada thermal power plant. If you are near to somewhere, I don't know, in the this Rayalaseema region, where are the plants, but you can imagine this is the generator placed over there. From there, there are different towers connecting to this generator to transmit the power. So that towers are having conductors, and that may have finite resistance. Then at somewhere like in our institute, let us say college, so is having three phase loads, let us say. That three phase loads have some impedances. This may be a big motor, or this may be some kind of compressors, etc. So each having some impedances. So in this way you imagine. And apart from that, the other thing is that we have a neutral line, and a neutral line has impedance. Neutral line has impedance. So what we need to do is that first read this question. Find the line currents. What are the line currents? First observe what are the line currents. Here it is given some notation: IA, IB, IC. These are the line currents. So line currents is nothing but IA, IB, IC. Next, solve the phase voltages at the load. Phase voltages is nothing but inside of the load, that you have to observe carefully. So this is the phase, this is the phase of the load, one phase, that is A phase, this is B phase, this is C phase. So now voltage across this shaded area is the phase voltages that you have to observe. That is VAN, VBN, VCN. These are the phase voltages. Next, solve the line voltages at the load. Line voltages at the load. Try to observe carefully. Line voltages at the load is VAB, means A to B. From here to here is VAB. This is line voltage. So A at positive. Next, similarly, VBC. So B to C. Similarly, VCA. So these are the three line voltages at the load. So generally load corresponding things suffixes with small case letters, and source corresponding things suffixes with capital case letters. So that is a general adoption, but it is not mandatory. It is not mandatory. So now let us approach in some form. So how to do that? First thing is that they didn't said anything about the system nature, but you have to observe. So the load impedance is given as ZY. ZY is equal to 6 plus J8. And this is same for A phase, B phase and C phase. This is a ZY, this is ZY, this is ZY. What does it mean? It is a balanced load. Balanced load. How we are saying this is balanced? Why? Because ZA is equal to ZB is equal to ZC is equal to ZY, which is equal to 6 plus J8. Can you tell me this in polar form? 6 plus J8. 10 at an angle of 53. 10 at an angle of 53 point, how much? 1313 ohms. See, A phase magnitude is the 10, B phase impedance magnitude also 10, similarly C phase. And angles of these are all having 53.13 degree. So all individual impedances are having same angle and same magnitude. That's why this is a balanced load. Next, so coming to source side, source, if it is not specified anything, if only one phase voltage is given, it is understood that source is also balanced. So with the assumption that, so EAN is equal to, so 120 at an angle of 0. And what we do is that we will consider that source is balanced and positive phase sequence or ABC phase sequence. Then after A, what phase we need to choose? B. So E B N is equal to same magnitude. Why? Because it is balanced and angle must be differ by 120 degrees. So this is EBN. So as because I know balanced and ABC phase sequence, so I am writing next as BN, so which is minus 120. Similarly, ECN, which is equal to 120 at an angle of plus 120 or minus 240. It's your wish. So I am writing plus 120. So these are the three phase voltages. So now we got three phase voltages and three phase impedances. Next, what else we need is that, what else we need is that, so one thing you should point this very carefully, the line impedances. So let me write line impedances as like this: ZL, Z small l, or if you want, you can write a line is equal to, line is equal to, how much is that? Zero point 0.2 plus 0.2 j. Zero point 0.2 plus 0.2 j. Now you have to imagine in this way. See that if line impedance is not there, if line impedance is not there, so can I put the diagram as like this? So you have some source, A phase source and B phase source and C phase source. Next is that I am pushing this line impedance to the load side for my convenience to solve the problem. This is the Z line and here is your Z Y, and similarly for other phases ZY and Z line, ZY and Z line, and here also you have ZY and Z line. So try to understand this little carefully. So this is B phase, so B phase should connect to B phase load. So in this way, and this is C phase, C phase should connect to C phase load. So in this way, so let me write A, B, C, and this is now, if I want, I can write small a, small b, small c. What I did from the above diagram is that these impedances are there, right? These are the line impedances. These I am trying to merge into the load so that some things are simplified easily. I'll show how it is. But I won't do any modification on the neutral. Neutral will be as it is. So there will be some neutral line impedance, that is as it is. This is small n, this is capital N. So this is Zn. Now, so try to see that this is IA. Previously they had given, this is IB, cross check it, this is IC. Now, in order to solve this problem, first what we need to do is that we need to find the neutral voltage, plus, minus. So once we know the neutral voltage, 99% problem is solved. So this is VAN and VN. So first what we do is that we will write the VN expression. What is VN expression? Now can you tell me? VAN divided by, tell me. I'll say this as ZT instead of every time writing Z line ZY. ZT plus VBN divided by ZT. Why? Because this B phase also same ZT. C phase also ZT. So this expression you try to copy and paste over here and try to follow this expression. This expression. Just I am putting aside. So see that this is ER by ZR. What is ER? VAN here in our case. In our case, it is VAN. So similarly, other things. EB is EB is nothing but C phase. VCN divided by ZT divided by 1 by Zn. Zn is Zn here plus 1 by ZT plus 1 by ZT plus 1 by ZT. Why? Did yeah. So it is all phases are having equal impedance. So directly I am writing ZR is equivalent to ZT, ZY is equivalent to ZT, ZB is equivalent to ZT. Is this clear for everyone? How I written the expression from this? Yeah. So now substitute all things. So it is very easy. Now you will get the Vn. So substitute all things and let me know the answer. So I can make further simplification. I can take ZT common here. Or first let us see what is ZT. ZT is equal to Z line plus ZY. So that is 0.2 plus 0.2 J plus ZY is how much? ZY. 6 plus 8J. 6 plus 8J. Can you tell me how much is this? 6.2 plus 8.2 J ohms. I got ZT now. So now VAN, that is 1 by ZT I'll write. So I'll write like this. 6.2 plus 8.2 J, this is 1 by ZT into VAN is, how much is the VAN? 120, right? 120. So there 120 also I can take common if you want, but let me write 120 at an angle 0 plus 120 at an angle minus 120 degrees plus 120 at an angle plus 120 degrees or minus 240 degrees. This is VAN, VBN, VCN. So numerator completed. Now what about denominator? 1 by Zn. How much is the Zn? Zn. Somewhere 6 plus 9j. 6 plus 9j. So 1 by 6 plus 9j. Sorry, 9j plus these all are same, so 3 times of this, right? So 1 by zt plus 1 by zt plus 1 by zt is 3 by zt. So I'll write directly 3 by zt is how much? 6.2 plus 8.2 j. Now calculate this and tell me how much is the Vn. This is what the Vn phasor. Carefully calculate. If you want, if you have doubt as you are in the starting stage, so you can calculate first numerator then denominator then numerator by denominator. It's your wish. Do it quickly. 120 into 1 at an angle z. Zn. Zn is 6 plus 9j na. See here, madam. Zn is 6 plus 9j. Zy is 6 plus 8j. Okay, got it? This one, I don't know where you are looking, but this one is the Z neutral. Is it visible? Yeah, yeah. So 6 plus 9j is neutral impedance. 6 plus 8j is that phase load impedance. Right. So quickly calculate. Which one? This one. Yeah. So yes, exactly. 0. This is very, very important observation. You no need to calculate all the things. This is 0 volts. Why? Because see, hereafter you can make this kind of observations that wherever balanced source is there, if you add up one at an angle 0, one at an angle minus 120, one at an angle plus 120, that means you are adding balanced voltage angles, that leads to 0. So balanced voltages, when you add up, it leads to 0. So directly you can put up this is equal to 0 volt. Then why we did so much of effort, that may you may ask. But if it is unbalanced, then there will be difficult situations. That's why, so as in to be practiced, so we calculated through the formula. So we realized that for a balanced system, neutral voltage is 0. Is this clear? Let me write very clearly that, note, note, this is very important observation which make you to simplify the problem greater extent. In any balanced system, in any balanced system, balanced system is nothing but balanced source and balanced load. Vn is equal to 0. Neutral voltage is 0. Right. Now, if Vn is 0, can you tell me what is Ia? Ia here. So these all are like based on the circuit, you can write the equations. You no need to remember anything. Basically, Ia is nothing but IR here in this way, like IR is equal to ER divided by ZR. So ER minus Vn, actually Vn is equal to 0, so ER divided by ZR. Is this clear? Yeah. But you no need to remember those things. Now you can observe this diagram. If this voltage is 0 volts, then entire VAN voltage, this side plus other side minus, generally we should show arrow mark, is this entire voltage is applied across A to N. So I can say here simply V small an is equal to V capital An. Is this clear? Where is the small an? In this diagram, where is the small an? I hope so. This ABC representation may give little confusion. Why? Because I merged this line impedance to this. So let me call this as A dash, B dash, C dash, different notations. Why? Because A may not be exactly here. So this is A dash, B dash, C dash. Virtual load. So we merged the line impedance also into load. So we call those terminals as A dash, B dash, C dash. What is exactly A is? Here is A. Here is B. From the diagram, you can see original diagram. You can refer, here is C. Now this is not VAN. This is VA dash N is equal to VAN. Are you getting? This is what the V A dash N means. A dash terminal to neutral terminal voltage. Neutral terminal voltage. Is this clear? Nobody is speaking. So V A dash N is equal to V A N divided by ZT. We already calculated ZT. So VAN is equal to 120 at an angle 0 divided by ZT. ZT is how much? 6.2. Yeah. So 6.2 plus 8.2 J. How much is this value? 10.28 at an angle of. No, no, no. I want both. minus 52.9 volts. Now, once we know this, we can find the line current or phase current. In star, line current, phase current both are same. I am not showing here bar, so even if it is not shown as a bar, it is equivalent to phasor. Sometimes in the literature, in the books, they will not show phasor in the form of bar, but they will say simply IA. So IA is equal to VA dash N divided by, sorry, uh, this is not the voltage, right? This is already current. That's what I am looking for. Uh, Actually, this is VA dash N is equal to VN. I made small mistake here. VA dash N is equal to VAN. Now, using this, IA is equal to VAN divided by ZT. So, let me write here. So, nobody identifying some of the things, silly mistakes. This you should identify. Which diagram? Let me finish this, then I will move on to that. So then IA is equal to VAN divided by ZT. So this IA we are calculating here. So now I already got the IA, so no need to write again IA. So this is not the volts, this is amperes. Voltage divided by impedance is the amperes. So from the diagram you can see that, or I will take this portion to avoid the confusion in this big diagram which things I am talking. Just like previously, I choose something in this way. So now you can see this portion only. So this portion, if Vn is equal to 0, can I say it is equivalent to short circuit? It is equivalent to short circuit. Why? Because Vn is 0. So here is the Vn. So Vn is equal to 0. Even if the impedance is there, it doesn't matter. It is equivalent to short circuit. Why? Because Vn is equal to 0. No current is passing through this. The neutral current In is equal to 0. Right. So if this is the situation, so VAN, capital AN is equal to VA dash N. Yes or no? If you write the KVL, these are parallel. So this entire segment is in parallel with this entire segment is in parallel with the source. What is this segment voltage? What is this segment voltage? This segment voltage, yellow color shaded segment voltage, is equal to source voltage. Then what is this branch current? This voltage across the branch divided by impedance. How much is the impedance? ZT. That's what I had written. So this branch current is IA is equal to voltage across this branch is VA dash N divided by ZT. VA dash N is equal to VAN, which we already know, divided by ZT. This is what I had written in the above. Is this clear now? Is this clear? Uh, that is a simple thing, right? So you have two elements in parallel. If the two elements are in parallel, is not the voltage same? Something like this. This is Z1 element 1. This is Z2 element 2. If this element voltage is V1, what about this element voltage? V2. No. That terminology may give wrong meaning, but I can say that voltage across the load is equal to source voltage. I may not say load and source are equal, but I'll say that in this way, load voltage is equal to source voltage. Got it? So if you have still doubt, you can think in this way. Here one element is there whose voltage is VAN. Let me write in this way, V capital AN. And here another element is there whose voltage is V A dash N. Here is the A dash, here is the N. And here to here some neutral impedance is there, Zn, whose voltage is Vn, this side positive, this side negative. Now you write down the KVL for this loop. What you will get is that this is the voltage. So let me start here, move in the clockwise direction from here, clockwise direction. So what you will get is that first VAN, VA dash N, sorry, plus Vn neutral voltage minus Van is equal to 0. As because neutral voltage is already, we observed that this is equal to 0. We already seen Vn is equal to 0. In that case, then V capital An is equal to V A dash N. Is this clear now? These are like once you, I hope you all need to practice lot of problems that I understood from this now. Why? Because these are KVL, KCL and series parallel concept issues, so that you could not follow means you are lacking there in understanding. So I request you to refer once again, so that corresponding portion. Okay, all of you, that may not be this person who asked, but I hope many peoples might have same doubt. But these are like very basic KVL and parallel circuit problems, so that you need to understand. That's why I told you. So thereafter I will be writing directly. So this is parallel equivalent. So this voltage is VAN, this load voltage also VAN. That is what V A dash N is equal to V capital AN. Okay, anyhow, so we got the line currents. Is that clear? Line current. Which line current? A phase line current. Now, once I know A phase line current, I can make in this way. A phase line current is this one. So, I can put up in this way. This is A phase line current. As because system is balanced and it is ABC sequence, I can directly write without calculating remaining two phase currents in this way. IB is equal to same as that of IA magnitude, which is 11.67, but angles are 52.9 minus 120. See how I am writing. Previously I used to write first one is 0, second one is minus 120, third one is minus 240 or plus 120. Here whatever angle is there for A, I will carry forward that current angle as it is. Apart from that, I will be putting minus 120. This gives the B phase current in simple way. You no need to calculate all things and taking this KVL etc. and proving that V capital Bn is equal to V B dash N. All those things are not required. So similarly, this is 11.67 at an angle of how much? Minus. So 172.9 amperes. Similarly, IC is equal to 11.67 at an angle of minus 172.9 minus 120 minus 120. So how much is this? 11.67. You can take Either of the things. So that is, you should understand clearly. What is this angle? This angle is B phase corresponding angle. From B, C should lag by 120 degrees. If I will consider A, from A it should lag by minus 240 or plus 120. Are you getting? If you have doubt in that way, I can make the expression in this way. So I want to take A as reference. So I will took here 52.9 degrees as what you said is plus 120. I hope now you got the clarity. Or ultimately answers will be same. See, you can check it. 11.67, this is or in other way, or or so 11.67. If I'll consider this B phase, from B phase it should be minus 120 further lagging. Instead of all these things, I hope you may confuse. Just let me proceed in the general way. I don't want to put up all things here itself. I want to inject you slowly all these concepts. So I am considering that whatever you have understood, if Ia is equal to I at an angle 0, Ib is equal to I at an angle minus 120, Ic is equal to I at an angle plus 120. This is IC, this is IB, IC. With this basic assumption, I had written these three equations. I hope now you understood. Is that clear? Is that clear? If Ia is 0 angle, then remaining is minus 120 plus 120. If this is non-zero, that will be carry forward. You can see that. So if 52 is here in place of 0, here also 52 is there in place of 0. Remaining everything as it is. These are the line currents. So I have 5 minutes, so I can finish. Phase voltages at the load. Now tell me, what are the phase voltages? This is the phase voltage VAN. Clear? Are you getting? V small an. Yeah, minus 240 also correct. So now you should not ask that doubt. Why? Because we said several times or. So then I can write here both are correct. 11.67 minus 52.9 minus 240. This also correct. So both are same. Okay. Right. So now I want the phase voltage. Phase voltage is VAN is equal to IA into ZY. Simple thing. So why IA into ZY is, you refer the diagram, this original diagram. This one. So VAN is equal to current through this into impedance. What is the current through this ZY? This portion, only this portion. Current through this ZY is IA. Why? Because this ZL and this are in series. So both are having same current IA. Line current is equal to phase current in case of star. This is star connected load. So phase current is IA, which is equal to line current. Are you getting? Here also same current IA. Now IA into ZY is VAN. IA into ZY is VAN. So let me put up those values here. IA is how much? Just now we calculated. 11.67 at an angle of minus 52.9. Don't forget the angle. If you do that, then you will get the wrong answer. So ZY is equal to ZY. Now only ZY, not line combination. Z is 6 plus 8J. ZY. 6 plus 8J. Now can you tell me this answer? Should be very fast in calculating these complex numbers. 11.67 at an angle of minus 52.9 into 6 plus 8j. Yeah. So 116.7 at an angle of 0.23. Yeah. So this is the poles. So what is this? This is the A phase load voltage. A phase load voltage. Similarly, now I can write directly B phase load voltage without calculating. So why? Because these all are balanced things. So 116.7 same magnitude, angles must be 0.23 minus 120. It should lag the A phase by 120. And VCN is equal to same 116.7, so 0.23 plus 120 or minus 240. It's your wish. So you complete this addition, subtraction, etc. So this is B part. B means our second part, I think. Phase voltages, load phase voltages. Next, what is the third part? What is the third part? Solve the, I think it is ABC. Sub questions are ABC. So I should follow this. Solve the line voltages. I told you what is the line voltage here? VAB. VA to B. Now can I write VA to B as VAN minus VBN? This is plus minus plus. This is VBN. So A to B voltage is equal to sum of these voltages by the KVL. Are you getting? Refer the diagram. Mostly from the diagram, many intuitions will come how to calculate. If you by heart it, it won't retain long time. You will face problem in the exam. But once you see the diagram, where is A, where is B? What is A to B voltage here to here? That you should see it. So now C part is that line voltages. Line voltages. So out of that, VAB is equal to VAN minus VBN. How I got this is by KVL again. How that KVL is, you have to look for that diagram. A to B voltage is from the A to B, this small a to B path voltage, here to here voltage. VAN plus VNB actually. Or instead of minus you can consider as VNB. VNB is equal to minus VBN. Are you getting? I am only shouting, nobody responding. 116.7 at an angle of 0.23 minus VBN is 116.7 at an angle of 0.23 minus 120. Can you tell me this answer? Fourteen point. No, no, no. It may not be that much decrease in amplitude. Why? Because it will be greater than the, we know line voltage should be root 3 times of the phase voltage magnitude. Yes or no? So, yeah. So that's the thing. Definitely, this should be 116.7 more than that value. So why? Because it is root 3 times of this 116.7. We know that line voltage is root 3 times of phase voltage. Yesterday I asked in the attendance link. So this is 120 and something 116. Oh, these many answers. She is giving different answer, madam. Check it again. 120 at an angle of, tell me, angle. Huh? Okay. Is this correct? Everyone got same thing? Some girls said some 220. That's why I'm asking you. So, can you verify this once again? Is it? Let me check. 116.7. So you should be very careful. I hope the answer is not this one. It should be in this way. 202.13 at an angle of 30 degrees. At an angle of 30 degrees. Anyone got this answer? So this is the right answer. So how I am saying is that your calculation is something wrong. Just by looking at, I know that line voltage magnitude should be root 3 times of the phase voltage. First thing. Here, what is the phase voltage magnitude is root 3 times of this phase voltage magnitude is 116.7. So root 3 times of this is square root 3 into 116.7 is approximately 202.13. 202.13. This is the magnitude. What about the angle is that? So line voltage should lead the phase voltage by 30 degrees. So the line voltage angle is equal to phase voltage angle plus 30 degrees. So phase voltage angle here is like if it is VAB, then A corresponding phase is the reference for us. A corresponding phase is VAN. How much is the angle? 0.23. Then plus 30 degrees. So this is 30.23. So in this way, you will get the line voltage orally VAB is equal to magnitude this angle. What might be your mistake is that you open one bracket here, close one bracket here, put minus, then open one bracket here, close one bracket while calculating. That is one thing. Other thing is that after angle also here you open one bracket and close one bracket in entering 0.23 minus 120. Then you will get the right answer. All of you cross check it carefully. Got the point? How I verified my answer, if I know the basic idea in star connection, the line voltage is root 3 times of phase voltage. Angle will be plus 30 degrees of the phase voltage. Is this clear for everyone? So in this way, you should cross check yourself that, so even if some calculation mistake is there, is it coming as root 3 times of phase voltage or not? That way you can cross check it. So once you said something like below 116, I blindly said that it is wrong. So somebody said around 120, I believed that it may be correct, but after seeing the angle, I got doubt that, so that is also wrong. So then you have to look for the things properly while entering in the calculator. So all of you try in this way, in your calculator, open the bracket, Then enter 116.7, then at an angle of 0.23, then similarly minus, then 116.7, then at an angle of, again open after angle symbol, or if you want, you do one thing, 0.23 minus 120, initially you calculate and put a side that this is minus 119.77. So directly enter at an angle of minus 119.77. Then close the bracket. Now tell me, are you getting this answer or not? Oh, okay. Then fine. Once we know this one of the line voltage, we can write remaining line voltages in simple way. 202.13 at an angle of 30.23 minus 120. Minus 120 degrees. Similarly, VCA is equal to 202.13 at an angle of 30.23 minus 240 or plus 120. It's your wish. So these are the line voltages, VAB, VBC, VCA. So in balanced system, you no need to calculate for every phase. Once you know one of the phase quantities, you can get remaining all phase quantities by the basic balanced principle. So this is one of the very important problem and important concepts are covered in this.